Now this is where, in analyzing this problem, the fact that A is diagonalizable really helps us more elegantly describe what's going on. We saw that the kth iteration was also equal to this vector x times lambda to the kth power y. And if we now expose that diagonal matrix, then we notice that raising that matrix to the kth power is just the same as raising each individual diagonal element to the kth power. Okay. And then we can again factor out lambda 0 to the kth power, in which case this particular element becomes 1, and the rest of these become these ratios. And what we see is that if lambda 0 is the largest in magnitude, then these elements all tend to 0. Therefore, this matrix ends up being a matrix that has a standard basis vector in the first column and zeros for the rest. So that would pick out the first column of matrix X times the appropriate element in our vector Y, chi0. And that then tells us again that eventually we end up pointing in the direction of the eigenvector associated with the largest eigenvalue in magnitude.